Hi, it's time for another math easy solutions. Today we're going to discuss further into polar coordinates and now go over a quick example, and that's example 2, and it's over here. It states convert the point 2 and pi over 3 from polar to Cartesian coordinates. So make sure to watch my earlier videos on the connection between polar and Cartesian coordinates. And basically the way we do that is, well, for this, in polar what we have is r is equal to 2 and theta is equal to pi over 3. So we want the basic xy axis coordinates, or the Cartesian coordinate system. So to do that, well, let's just draw our xy curve. xy, so what this r equals 2 and theta equals pi over 3 means if you have a point here, then a distance to the origin O is going to be r equals to 2, and then the angle with this x-axis like that is theta is equal to pi over 3. So what we have is here, if we have the polar coordinates, I'll write that for p, and this is 2 pi over 3. So let's say we want to know what the equivalent in Cartesian coordinates are, x, y, like that. Well, to solve that, as I've done before, what we do, we could just draw a triangle like this and use trigonometry to draw a right angle triangle perpendicular to the x-axis. So the distance across here is y, distance across here is x. Yeah, so what we have is, so in polar that's what it is, and then we need to find the x and y's, and we could just use the Pythagorean theorem slash trigonometry. And as I went over before, the sine of this, or sine theta, is going to be equal to opposite over hypotenuse, so y over r. So y over r, in other words, this is going to be y equals to, just move the r on this side and then write 2 in there, so y equals to 2. Let's move it over, 2 times sine of theta, which is pi over 3. And likewise, the cosine is adjacent over hypotenuse, x over r. So we have x over r, move the r on the other side, and then we get x equals 2, and then r is 2. So 2 times cosine pi over 3. And now we can solve these ones, as we know the exact trig ratios for cosine and sine pi over 3. And I'll put the link in the description below on a video I made on exact trig ratio. So what we could do is, if we recall a quick memorization tool, is let's just draw a just symmetric triangle like this, where all the sides are length 2. So we draw one that's 2, 2, and this one's 2 as well, but what I'm going to do is I'm going to split this in half, like that, and this is 1, and this is 1. So it's a perfect triangle like that. I think this is called an equilateral triangle, so all the angles are the exact same, but they all have to add up to 180 degrees, or pi. So in other words, we split this up into 3s, like that. So this one is pi over 3 as well. So what we have now is we have ratios from here to here, and this one's actually, this distance across is square root 3, because using the the Pythagorean theorem, square root 3 squared plus 1 squared equals 2. Well, that just, the square root in that cancels. This equals 3 plus 1. 1 squared is 1. This equals to 4, which equals to 2 squared. In other words, this squared. So this is the Pythagorean theorem. So we could just do that, and you'll see that that's actually it. And there's our 2 squared. I'll just write Pythagorean theorem. This equals to that. Pythagorean theorem, like that. I believe that's spelled correctly. Yeah, actually I think there's a A at the end. E-A-N. Yeah, theorem like that. So from that we could see, now do the exact same thing and see the exact trig ratio. So sine of pi over 3, that's opposite over adjacent, that equals, opposite over hypotenuse, square root 3 over 2. So that's what it equals to. So we could just throw that inside to the above. I'll do that in a bit. And we also know that cosine pi over 3 is equal to adjacent over hypotenuse, so 1 over 2. So then the sine is square root 3 over 2, so this equals to 2 times sine pi over 3 square root 3 over 2. The 2's cancel. This equals to square root 3. So the y coordinate is equal to square root 3. And the x coordinate, this equals to, cosine is 1 over 2. So this equals 2 times 1 over 2. The 2's cancel. We're left with equals to 1. So in other words, the x-coordinate equals to 1. So then this point here is equal to c, and I'll just write that for a Cartesian. This is going to be 1 and square root 3. Yeah, and that is our point over there. So we could sum this up. So thus the polar point, polar point, and I'll write this as P, and this is 2 and pi over 3, r is 2, theta is pi over 3, equals to the Cartesian, and just for completeness sake, write this all down, Cartesian point, and I'll write this as C, and this is 1 and square root 3. So these are the exact same points on the graph of the various coordinate systems. So the same point is equivalent to this in the polar and Cartesian coordinates. And yeah, that's how you can go about and solving this and moving around back and forth from Cartesian and polar coordinates. So anyway, that's all for today. I believe in the next example I'll go over going from Cartesian to polar, etc. So stay tuned for that video. And anyways, thanks for watching and stay tuned. Yeah, actually, like always, you can download these exact notes in the link below. I forgot to mention that. Like always, and let me know if the link doesn't work. I'll update it. Anyways, thanks for watching and stay tuned for another math easy solution.